Okay, here I'm going to show you a couple slides on some optical fiber types. So in Chapter 5 so far we've talked about fiber geometries, the different types of fibers. We've also talked about dispersion and bandwidth distance product, limitations on fibers. And now I'm going to give you a few short videos on different fiber types. Well, the main distinction between different types of fiber is between multimode and single mode. Multimode fibers are usually used for lower data rates, short distances, typically in data centers and the like, maybe inside of a building, whereas single mode fibers are used for long distances and wide area network links. Okay, longer distances. Generally speaking, we've got much larger bandwidth distance products for single mode fibers due to the absence of modal dispersion. Okay, and we're also more likely to be using lasers for single mode fiber and LEDs for multi-mode fiber. Although I will explain where there's a new type of laser that's very often used for multi-mode fibers these days, and this has actually become the norm. What I'll do is I'll talk about different fiber types by looking at the Corning product line, and I've sort of divided the list up into three different categories here: multi-mode, single mode, and specialty. I will talk about multi-mode fibers in the next slide, and we have both the Infinicore and the clear curve multi-mode varieties. In the single mode product fiber line, we've got SMF-28 varieties, three different varieties of SMF-28. SMF-28 has sort of been the industry standard single mode fiber for many years, produced by Corning, and so over the years that product line has expanded. It includes three different varieties currently. Other varieties of single mode fiber include leaf, clear curve, single mode, and Vascade fibers. I'll talk about all of them in more detail. And then we also have the specialty fibers. I'll talk a little bit about them right now. One type of fiber that is very common as a specialty fiber is a polarization maintaining fiber. I think I've mentioned it in one of the videos before, that when you put light into a fiber, generally you don't have any control over the polarization properties of that light coming out of the fiber. Usually with lasers we are putting polarized light into a fiber. Laser light is generally polarized, and if you go into the fiber for short distances, it'll come out polarized also. However, you don't know what the orientation of that polarization will be. If you go long distances, generally speaking, you're going to get a whole mixture of different types of polarization states: circularly, elliptical, linearly polarized, and so one would say that the light is not polarized on the way out. And for various applications, especially in fiber optic components and fiber connects between integrated optical components, polarization maintaining fiber may be needed. And in polarization maintaining fiber there is a particular axis of symmetry in the fiber, and in fact what they do is they have the core, but then they put as part of the manufacture put some sort of a stress into the glass surrounding the core. Okay, so out in the cladding here they'll put some sort of a stress on that glass which will cause the core to be birefringent, and in a birefringent material you have very different refractive indices for the directions of polarization, and if you launch light either along or perpendicular to that axis that is sort of defined by this stress, it's called a stress member, then the light will stay polarized along that axis through as it goes through that fiber. It can be very useful. They're expensive, and alignment of polarization maintaining fibers with integrated optics devices is a pretty good challenge usually. Another type of specialty fiber that's available is erbium-doped fiber. This is used in creating erbium-doped fiber amplifiers, EDFAs. Okay, so it's more or less normal optical fiber, but it's been doped so that the core has these erbium ions in it. There's also a whole bunch of other, if you click on the Corning website, a whole bunch of other types of specialty fiber, a lot of them specially made for high temperature use and things like that. In the next video, I'll go on to describe the multimode fibers in more detail. Thanks.